Hello students, I am Professor Navneet Kaur from EC Department, SIRT College, Bhopal. Today I will be taking lecture on subject digital communication. The topic of my lecture is data modulation. In this lecture, I will be discussing basic principle behind the working of data modulator. Then I will be discussing the transmitter and the receiver block diagram of data modulation system. Further, I will be discussing limitations of the data modulation system. And finally, I'll discuss application of data modulation system. Now to start with my lecture, first we will discuss what is data modulation. Data modulation is an analog and digital to analog physical conversion technique which is used for transmission of voice information. It is the simplest form of differential pulse tone modulation where the difference between successive samples are encoded into one bit data stream. Whereas in DPCM, the difference between successive samples are encoded into n bit data stream. So here, only the change of information is set. The present sample value is compared with the previous sample value and the indication whether the amplitude is increased or decreased is set. In data modulation, the purpose is to achieve high signal to noise ratio. So, here we use oversampling technique, that is, the analog signal is sampled at a rate several times higher than the Nyquist signal. So, here the signal is oversampled. This increases correlation between adjacent samples of the signal, which results in small prediction error so that error can be encoded using only single bit. So sampling rate is much higher and the step size after quantization is of smaller value. This technique is known as data modulation. Here we can see the basic block diagram of the data modulation system. Now here the input signal is approximated to step signal by the data modulator. The difference between the input signal and the staircase approximated signal is calculated, which is termed as EKTS. So here we can see at the input the sampled input of the input signal xt, and x cap KTS represents the predicted value, which is calculated from the previous sample. The difference between the two samples is calculated, which is represented by error EKTS. EKTS is given to one bit quantizer, which will generate value VKTS. VKTS is confined to only two values, plus delta and minus delta. If the difference between the sampled input and the predicted value is positive, the value of VKTS is plus delta. Whereas if the sampled input is less than the predicted value, the value of VKTS is given by minus delta. So if the difference is positive, that is plus delta, the difference is encoded as 1 bit. Whereas if the difference is negative, that is the value of VKTS is minus delta, in that case, the encoded output will be 0. Here, in this block diagram, we can see that the previous sample is added to the value of VKTS to generate the present approximation, which is UKTS. So UKTS will try to reach the value of XCTS. UKTS is given to the delay unit, which delays the signal UKTS by TS samples and will generate the predicted value X cap KTS, which is also known as UK minus 1T. So in this case, the predicted sample will try to reach the sampled input. So here are the important equations which are used in the transmitter of the data modulator. As per the block diagram, we can see that the error signal E and T is given by the difference of sample signal xt and the predicted sample, which is last sample approximation of the staircase waveform. We can call U and T here x cap and ts is also termed as un minus 1 ts, which is last sample approximation of staircase waveform. V and ts is given by expression delta signum of E and ts. We know signum function can take only two values, plus 1 and minus 1. So here also V and ts can take only two values, plus delta and minus delta, where delta is the step size. Plus delta value is generated when x and ts is greater than equal to approximated signal x cap and ts, whereas minus delta value is there when x and ts is less than x cap and ts. So corresponding to plus delta, binary 1 is transmitted, whereas for minus delta, binary 0 is transmitted. So 1 and 0 single bit represents the delta modulator output. Now, as discussed in the previous slide, the present sample approximation UNTS is generated when the previous sample approximation UN minus 1 TS is added to B and TS, which can have value plus delta or minus delta. So, depending on the size of E and TS, one bit quantizer produces an output step of plus delta and minus delta, and corresponding to this, binary 1 or binary 0 is transmitted respectively. Now here we can see the basic operation by the use of the waveform. Here we can see the basic signal MT, or we can say XT also. Now this is the staircase approximation which is generated by the delta modulator. Now this clock waveform is used to represent the timings for comparing the samples, where the samples are compared after every TS. Now here at time t1, the samples of the present sample of input signal and the staircase approximated signal is compared. Now here we can see that the message signal is greater than the approximated signal. So approximated signal will be added to plus delta because the difference between the two samples is positive. So BKTS will have value plus delta. This plus delta value will be added to the previous sample approximation. So it will be increased by the amount delta. Now it will be delayed by amount TS. Now after T2, which comes after TS interval, again the samples of the input signal and the approximated signal is compared. Here also we can see that the sampled input of the message signal is greater than the approximated signal. So the difference will be positive and BKTs will have value plus delta. So here the approximated signal will be added by plus delta and the amplitude will be increased by plus delta. Now plus delta will be, this value will be for time TS because the UKTS will be delayed by time TS and it will generate UT minus 1 TS. Now after another TS interval, see at time T3, again the approximated signal and the input signal is compared. Here we can see that the approximated signal is greater than the input signal. So in this case, the error signal, which is the difference between the two samples, will be negative. So the BKTS will have value minus delta. This minus delta will be added to the present approximated value, and so the present sample approximation will be decreased by plus delta, will be decreased by delta unit, and here we can see there is decline in the amplitude. So this will give the present sample approximation UKT. Now this process, and here we can see the delta modulated output, that whenever the BKTS is having value plus delta, 1 is transmitted, whereas when BKTS is having value minus delta, 0 is transmitted. So corresponding to the value of BKTS, we have delta modulated output, which is either 1 or 0. So only single bit is transmitted as delta modulated output. Now here we can see the receiver block diagram of the delta modulation At the receiver end, the single bit which represents the data modulator output is transmitted via the channel. When this single bit is transmitted, it is first decoded by using the decoder circuit. Now decoder will generate BKTS. BKTS will be having value plus delta when 1 is received, when 1 bit is received. Whereas BKTS will be having value minus delta when 0 bit is received. Now this BKTS will be added to the approximated signal UK minus 1 TS. As we know, when UK minus 1 TS is added to BKTS, it will generate UKTS. So this UKTS, when given to the delay unit, which delays the signal by one sampling period TS, it will again generate UK minus TS, and by the time the next data modulated bit is received. So now these two signals will be added, which will generate again present sample approximation, which will be UKTS. Now this UKTS is having values closer to the input signal XKT. So this UKTS will be given to the low pass filter. The low pass filter has the cutoff frequency equal to highest frequency in the XT. This filter smoothens the staircase signal to reconstruct XT. So at the output, we will get the signal closer to the message signal XT. Now coming to the disadvantages of data modulation. Data modulation has two major drawbacks. The first one is slope overload distortion. Now, in slope overload distortion, the rate of rise of input signal is so high that the staircase signal cannot approximate it. So here we can see in the diagram that the rate of rise of this message signal xt is very high as compared to the staircase approximated signal. Now, here the staircase approximated signal cannot follow this message signal whose slope is very high, because here the step size is less. So the staircase signal is changed by very small amount as compared to the message signal. So there is large error between the staircase approximated signal and the original input message signal xt. This error or noise is known as slope overload distortion. To reduce this error, the step size must be increased when slope of the signal is high. Now, another disadvantage of data modulation system is granular noise. Granular noise occurs when the step size is too large compared to small variations in the input signal. Now here we can see that in this portion of the signal, there is very small variations in the input signal, whereas the approximated signal changes its amplitude by delta unit after every TS. So the input signal is almost flat, whereas the staircase signal keeps on oscillating by plus minus delta around the signal. Thus there is an error between the input and the approximated signal, which is called granular noise. The solution to this problem is to make the step size very small, so that the error between the input and the approximated signal can be reduced. Now, finally coming to the applications of the data modulation system. Voice transmission systems such as telephone and radio communication prefer this modulation technique. Data modulation is most useful in systems where timely data delivery at the receiver is more important than the data quality. This modulation system is applied to